In this video, let's start working on this decision tree question. So we have a football club that considers making a contract offer to a young player, but it's not certain that he will be a valuable player. So there are three options. He could be a valuable player, he could be mediocre, and he could also fail. Now, if the player is valuable, the payoff to the club is 12 million euros. If he's mediocre, it's gonna be 2 million euros. And if the player fails, then the club loses 4 million because they have to train him, and that would be a loss to the club. Now, to reach a decision, the club can offer an internship. So in the internship, they would test him. Now, at the end of the internship, the expert who's gonna test him is gonna say whether the player is talented or not, and the internship costs 500,000 euros. Now, we also know the probability distribution over here. We know the probability of being talented and valuable, the probability of being talented and mediocre, and so on. So we have these cells over here. Okay, so let's start working with the probabilities. The first step is to always understand what's happening in the probability table, because we have the joint probabilities, so talented and valuable, talented and mediocre, and so on. But we also need to know the total probabilities. The probability that the player is talented is going to be the summation of these three. So it's 0.05 plus 0.40 plus 0.05, that's going to be 0.5. And by the same logic, we have a look at the probability of not being talented, which is 0.05 plus 0.10 plus 0.35, which also is 0.5. And they add up to 1. And that's exactly what we want, because the probability must add up to 1. Now, with the same method, we want to find out the probability of a player being valuable. So the probability of being valuable in total is 0.05 plus 0.05, which is equal to 0.10. The probability of being mediocre is equal to 0.40 plus 0.10, that's equal to 0.50. And the probability of being a failure is equal to 0.05 plus 0.35, which is equal to 0.40. They also add up to 1, which is exactly what we need. So we completed the probability distribution table. What it's also important is to go to the second step and have a look at the payoff. And to make this question even more practical, let's actually note the steps to understand the method of solving. This is going to be our first step to understand the probability distribution. We're going to the second step to understand the payoffs. Now, when we have no internship, so over here we can see that no internship, we have three probabilities: the probability of being valuable, the probability of being mediocre, the probability of being a failure. So without an internship, that gives us a payoff of a valuable player of 12 million euros. So that would be 12 million euros. The mediocre player would give us 2 million euros, and the failure would cost us 4 million. So it's a loss to the club of 4 million. Now, if there is no contract, so contract offer over here, and there is no offer, there's no money involved, so that would be a payoff of 0. No gain, no loss. Now, if we have a look at the option with the internship, so when we actually invest in the internship to test the player, of course we spend the 500,000 euros, which is the same as half of a million. That's half of a million. So, by having a payoff of 12 million after we invest a half of a million, the net payoff, the net gain from him is going to be 11.5 million. For a mediocre, it's going to be the net of 2 million in payoff and half a million in cost for the internship, 1.5. And if he's a failure, we invest 4 million in him plus also for the internship, so we lose in total 4.5 million. And if we do not do anything with the money, if we do not do anything with the contract, if we do not acquire the player, then we have no benefit from him. But however, we have tested him in the internship, so we still have a loss of half a million, of $500,000. And the same logic goes here. Whether he's talented or not, we're still having this possible payoff. So 11.5, which is the same difference between the 12 and the 500,000 for the internship. And the same numbers apply to the mediocre player, to the failure, minus 4.5. And whether we don't give him a contract, then we only spend money on the internship, which is half a million. Now, that was the second step. After that, we have to start working backwards. We have to start working with the conditional probabilities in this column. We'll go over that column and we'll get to the final decision where we we'll compare the expected values, but we'll do so in the next video.